Welcome everyone to the AI Research Roundup. I'm your host Alex, and today we're diving into some exciting developments in AI. We'll be looking at a paper titled Lumina-Image 2.0a Unified and Efficient Image Generative Framework, which was just published on March 27, 2025. So this paper introduces an advanced framework for text-to-image generation, building on previous work. The core ideas revolve around two principles. First, unification, where they use a single architecture to handle both text and image tokens together. And second, efficiency, focusing on faster training and inference without losing image quality. Pretty interesting stuff. Okay, and speaking of the framework itself, the researchers have actually made their work public. What we're seeing here is a snapshot of their GitHub repository for Lumina-Image 2.0. So it looks like they've released the source code, model checkpoints, information for fine-tuning and inference, and even a demo script so people can try it out directly. It's always great to see projects being open source like this. Really helps the community build on these advancements. Okay, so to give you a better idea of what this Lumina-Image 2.0 can actually do, let's look at some examples they provided. This figure shows a range of high-quality images generated by the model. You can see it handles different things, like creating ultra-realistic photos, generating images with specific text in them, different artistic styles, even understanding prompts in multiple languages, and doing some logical reasoning. It also shows examples of generating multiple related images together. Pretty impressive variety and quality overall. Alright, so we saw what it can do. Now let's peek under the hood a bit with this next figure. This gives us an overview of the Lumina-Image 2.0 framework itself. It really shows those two core ideas we talked about. First, there's the unified captioner, or UniCap, which takes various images and generates those really detailed, multi-level, and multilingual descriptions we mentioned are important for training. Then, that detailed caption feeds into the main model, the unified Next-DiT, which you can see processes both the text and the image information together in these single stream blocks. That's that unification principle in action. Okay, so building on that framework overview, this figure zooms in specifically on the unified Next-DiT block we just mentioned. It actually compares Lumina-Image 2.0's approach, which you see labeled ours down here, with several other well-known architectures like PixArt, Stable Diffusion 3, and Flux. The key difference highlighted is that Lumina uses a single stream block, processing the text and image tokens together in one sequence. This is different from, say, the cross-attention used in PixArt, or the double stream blocks in South Dakota 3 and Flux. It really underscores their unified approach at the core level. Alright, so after looking at the architecture details, this table gives us some concrete performance numbers. It compares Lumina-Image 2.0, which is down here at the bottom, against a bunch of other text-to-image models on several standard benchmarks, like Generative, DPG, and T2I Comp Bench. These basically test how well the models understand prompts, like counting objects or getting colors right. And, well, Lumina-Image 2.0 stacks up really well. It gets the best overall scores on DPG and T2I Comp Bench, and second best on Generative. The paper suggests this strong performance, especially on DPG, is thanks to those detailed captions generated by UniCap we talked about earlier. Okay, so beyond those specific benchmarks we just looked at, this next table shows results from a different kind of evaluation. This uses ELO scores based on comparisons in the artificial analysis text-to-image arena. Think of it like a ranking system. Lumina-Image 2.0 gets an overall ELO score of 982 here. So, looking at the table, that puts it ahead of models like DAL-E 3 and South Dakota 3 medium, but behind the Flux models shown. It suggests Lumina holds its own, performing quite competitively, even if it's not at the very top of this particular leaderboard. Okay, and speaking of performance, this figure highlights another interesting capability of Lumina-Image 2.0, its multilingual understanding. What we see here are examples where the model generated images based on prompts given in 5 different languages: Chinese, Japanese, English, Russian, and German. And you can see it successfully creates images like dragons, cats, and landscapes based on these non-English prompts. According to the paper, this works even in a zero-shot setting, which is quite impressive and likely ties back to the multilingual data generated by UniCap. So, building on UniCap's capabilities, this next figure directly compares how well it generates those detailed captions we've been talking about. It puts UniCap, which is labeled Hours, side by side with 2 other systems, ShareGPT 4volts in Florence, and asks them to describe complex images, like a busy museum scene and an ad with lots of text. Well, the results suggest UniCap does a better job, providing more detailed and accurate descriptions, especially when dealing with intricate scenes or reading the text correctly within the image. This really highlights the quality of the captions used to train Lumina-Image 2.0. Okay, so seeing how well UniCap generates those descriptions really underscores the foundation Lumina-Image 2.0 is built on. Alright, wrapping things up. Lumina-Image 2.0 really highlights how crucial high-quality training data is for top-tier image generation. Its unified approach and strong multilingual abilities also point towards more capable and efficient models down the road. It's definitely impactful work. Well, that's all for today. Thanks for tuning in to the AI Research Roundup. I'm Alex. See you next time.